Thanks for tuning in to check this out mathematics again. And in this is the series of videos where we have been talking about the Pythagorean theorem, Pythagorean triples, and 3 formulas that generate Pythagorean triples. And so this is part 3 of that series. And in this part 3, we're going to talk about the second formula that generates Pythagorean triples. That is a, b, and c values, where a squared plus b squared equals c squared. So I encourage you to like these series of videos and subscribe to the channel. Check this out mathematics, and put some comments down below. And so let's check this out. Let's get into this script is out of order, but that's okay. We're going to fix it. There we go. 13, 14, 15. There we go. All right. So in the previous video, we talked about this formula, 2m plus 1, 2m plus 2m squared, and 2m plus 2m squared plus 1. This is a formula that generates Pythagorean triples. So if you are given m as a basis, then this formula will give you Pythagorean triples, where a squared plus b squared equals c squared, and c is 1 more than b. That was the generating formula from the previous video. And now you're maybe wondering, are there other formulas that generate Pythagorean triples? And so before we introduce those formulas, introduce the second formula, let's bring up a couple more triples. So here we have a Pythagorean triple. That's a set of whole numbers that are solutions to the Pythagorean theorem. And here we have 1, 8, 15, 17. And so let's check this out. If we take a squared plus b squared equals c squared, and we say 8 squared plus 15 squared, and that will give us 64 plus 225, and 64 plus 225 will give us 289, and 289 is 17 squared. And so 8, 15, 17 is a Pythagorean triple. All right, let's show another Pythagorean triple that will be useful in generating this second formula for generating Pythagorean triples. And so here we have A, B, and C equal to 20, 21, 29. Another Pythagorean triple. And let's see that that's true. If we have A squared plus B squared equals C squared, and we say A is 20, so that's 20 squared, plus B is 21 squared, so A squared plus B squared. And let's see, 20 squared is 400, and 21 squared is 441. And if we add those values together, we get 841. And 841 is 29 squared. If you multiply 29 times 29, that gives you 841. And so 20, 21, 29 is another Pythagorean triple. And so let's use those two Pythagorean triples, 8, 15, 17, and 21, 20, 21, 29, to illustrate this second formula that generates Pythagorean triples. And this formula uses a pair of numbers as the basis. Pair of whole numbers. So let's take two values, 4 and 1. And then let's manipulate those numbers in such a way that we will arrive at a Pythagorean triple. And so let's multiply those numbers together. 4 times 1. And then double that product. And so that's 2 times 4 times 1, that's 8. And then let's take those two numbers, 4 and 1, and let's square them and subtract them. So we're going to square 4 and square 1 and subtract them. And so 4 squared is 16. Minus 1 squared is 1. And 16 minus 1 is 15. And so this is coming together right. And this time, let's, for the last part of this formula that generates Pythagorean triples, let's take the numbers 4 and 1 again and square them and add them together this time. And so 4 squared is 16, plus 1 squared is 1, and that gives us 17. Okay, so with these two values, 4 and 1, we were able to generate the Pythagorean triple, 8, 15, 17. By going through this algebraic process. And so now let's actually write out the formula with some variables. Okay, so the idea is that we're going to choose two values, and we will call them m and n. And then let's remember what we did with those values. First, we multiplied those values, 4 and 1 in this example, and then doubled them. And so we're going to multiply m and n, and then double that product. And that's going to give us the a value. And then let's remember what we did previously. We had previously we took the two numbers, 4 and 1, we squared them and subtracted them. So in this variable arrangement, we would have m and n, and we would square them and subtract them. And that's going to give us the b value. And then let's remember the third part of this formula that generates Pythagorean triples. We squared them and added them together. We squared the 4 and squared the 1 and added them together. So that would mean we would take m and n and square them and add them together. And that gave us the c value. And so now with these two values, m and n, and this manipulation of m and n, we have arrived at a Pythagorean theorem, ABC, where a squared plus b squared equals c squared. And that's our second formula that generates Pythagorean triples. So let's see that this works. Remember, we had that Pythagorean triple 20, 21, 29. And that comes from the m and n combination of 5, 2. So we're going to say mn is 5, 2. And then we're going to go through the process. That's 2mn and 2m, excuse me, and then 2mn and then m squared minus n squared and m squared plus n squared. Okay, and so there is our formula that generates a Pythagorean triple. And let's go through that. So if we take 2mn, and so we say 2 times 5 times 2, that's 10 times 2 is 20. Okay. All right then. And then let's do the next portion of the Pythagorean, the formula that generates Pythagorean triples here. And that's the m squared minus n squared. And so we're going to take 5 squared minus 2 squared. And that's 25 minus 4. And that gives us 21. All right. And now then, let's square them and add them together. So that's 5 squared minus 2 squared equals 25 plus 4, and that's 29. And so you can now see the formula that generates Pythagorean triples, and another example of an m and n value that through this formula gives us the Pythagorean triple 20, 21, 29. All right, very good. Now, we want to clarify something about this formula. So this is a formula that generates Pythagorean triples. Okay, this is a formula that generates Pythagorean triples. And that formula is 2mn and m squared minus n squared and m squared plus n squared. That gives us an a b, and a c, where a squared plus b squared equals c squared. And since there is a subtraction happening here, the m value must be larger than the n value. So where m must be larger than n. Okay, so that's our second formula that generates Pythagorean triples. Okay, and so we had our we have now two formulas that generate Pythagorean triples. We have this one. If we have a basis of m, then we have 2m plus 1, 2m plus 2m squared, and 2m plus 2m squared plus 1. That was our first formula from earlier. And then we have now shown a second formula with mn being our basis. And with those two values, we can manipulate them this way. 2mn, and then m squared minus n squared, and m squared plus n squared. And so now we have two formulas that generate Pythagorean triples. And so that's pretty cool. We have this Pythagorean theorem, a squared plus b squared equals c squared. Pretty remarkable. And for the sides of a right triangle, how they're related. And then not only that, but we have formulas that generate Pythagorean triples. And so those were the first two. And we have one more to cover. And so that's what's going to come up in our next video. And so I encourage you to tune in for that part 4 of this video series, where we talk about the third formula for generating Pythagorean triples. And then stick around for the video after that, where we can see what's behind me. You can check that out. And so I encourage you to subscribe to this channel and give me a thumbs up and put some comments down below. Thank you very much. Mr. Donald will be back.